fix that. All right, everyone. Let's go over this, our final stat for the class, which is profile analysis, aka mixed model ANOVA. Someone's actual dissertation here. So this person was interested in eating disorders. They wanted to compare the personality profiles of teenage males with bulimic symptoms, most of whom were on a high school wrestling team, to a control group of teenage males who did not have bulimic symptoms. So folks in both groups took the NEO-PI, just like in lecture. It's a 5-factor personality questionnaire. And this person had the following 7 hypotheses about how bulimic and non-bulimic teenage males would differ. So first of all, you got 1 through 5 is that bulimic males would be higher on neuroticism, extroversion, agreeableness, and conscientiousness, but lower on openness. So that is how they thought the between groups variables would play out for each of the subscales. So then they have 2 hypotheses about the relative ordering of those subscales for the bulimic males and non-bulimic males. So they thought that the most salient, that is the highest or mean personality traits of bulimic males would be extroversion and openness, that's E and O, and that the highest sort of most prevalent or mean personality traits of the control males would be agreeableness and conscientiousness, A and C. So because, again, all of the NEO-PI subscales have the same scaling, we are going to, or the appropriate analysis that this person used was a profile analysis or a mixed model ANOVA. So step 1 is, let's go ahead and actually run the profile analysis itself. You get to do the fun part right up front. So I've opened the data file over here. I'm going to go to Analyze, going to go to General Linear Models and Repeated Measures. So I give you very specific information here, so I can actually grade this thing easily. You, when you first open this box, you got to tell it, hey, I've got a repeated measures variable. I want you to call it NEO-PI. How many levels? 5 subscales. Click Add, click Define. So it starts out and it wants to know what variables correspond to the 5 levels of NEO-PI. Well, in order, make sure you pop these over there, NEOAC. Otherwise, it's really hard to grade this assignment. Boom, like that. So where are we at? We have to then take the bulimia group, this one, and we put it in the between subjects factor box. And now we're going to get some options. This is a between subjects 2 level, 5 within subjects 5 level. So I tell you to click plots, and then specifically to move the within IV NEO-PI from the factors box to the horizontal axis, and then the bulimia group, which is the between subjects, as separate lines. Make sure you click Add and then Continue. Then click the EM means button. We have to do this because we need to make sure we can hit paste and add that compare bulimia group later on. So move the two-way interaction, there it is, from the factors box over to the display means for box, and click to continue. Click on the options button. So to get descriptive statistics and to get homogeneity tests, click continue. And then do we click OK? No, we click paste. When we click paste, we get this output. And I tell you, you've got to add some stuff here to get the first set of simple effects tests that compares bulimia group between the levels. So to do that, we go to this line that says E means right here, and we make it look like this. So we're going to type compare. I don't know if it has to be in all caps. And in parens, I'm going to actually copy this so I don't make a typo. Bulimia group. What's that going to do? It's going to give us an extra set of univariate simple effects tests that compares bulimia group within each level of the other variable, that's NEO-PI. So once we have this, we can select run on the top menu bar and all, run all. That's going to run the profile analysis of repeated measures. All right. So where is it? It's been one of those days. Oh, it's still running. Geez. grinding away. I don't know what makes this so hard. Oh, there we go. So that one took a while to run, didn't it? There's all sorts of stuff in here. So let's start out with, was the sphericity assumption violated? That is, was Mauchly's test of sphericity sig less than 0.05? So let's scoot down, look at what we got. We didn't have equal sample sizes. First of all, note that 41 and 32. These are the means that are compared in the interaction. We talked about those in lecture. These are the means that are actually for the main effect of the within subjects factor. They're combined across the two between groups. Not very meaningful usually. So here's Mauchly's test of sphericity. And Mauchly's test of sphericity tests two assumptions: that there's homogeneous variances and that there's homogeneous covariances. And it's an assumption that's often violated. So Mauchly's sig is 0.001, or it's actually less than 0.001. So was the sphericity assumption violated? You bet your butt it was. Sig is definitely less than 0.05. It's teeny tiny. I mean, it almost always is violated, gotta be honest with you. So we're gonna write the results of Mauchly's test in APA format. We need that for the write-up. It's not just because I'm a meanie. So I'm gonna copy that and paste it here. And just so you guys can see it better, let me do that. So where do we get all this crap to fill in here? Well, right here, W is Mauchly's. Make sure you put the leading zero. 0.50 is our Mauchly's value, so 0.50. Our chi-square equivalent to that has 9 degrees of freedom, so I put 9 there. And what's it asking for here? It's asking for the total sample size. So this is a Mauchly's test for the big analysis. So we need the total sample size in here. So where is that? Well, that's up here actually. You've got a total of 73. That's 41 plus 32. You've got a total of 73 participants in this study. Scooching back down to Mauchly's. Our actual chi-square value is here. It's 48.04. And is P less than 0.05? You bet it is. So that is Mauchly's. And you need that for your APA write-up. So based on the output table called test of within, based on the answer above, what line of the ANOVA results should you therefore interpret for both effects involving the within subjects, IVA to avoid type 1 air inflation? I just have so many words sometimes. So here's our test within subject effects. What we're going to use greenhouse geyser. Let me just make it easy. So let me go ahead and fill that in. Greenhouse geyser. And that is the line of results we will interpret for all the effects that are in here. Okay, using alpha of 0.05, is there a significant main effect of neo-PI subscale? That's also called the test of flatness. So here we are, neo-PI subscale, greenhouse geyser, sig. So yeah, there is a main effect of neo-PI subscale. And that's just like a main effect in any two-way ANOVA, to be honest with you, except here it doesn't always have meaning. Why is this main effect probably not very meaningful? Great question. So what is this main effect here? Let me show you what it's comparing. So note that you've got the mean of neuroticism for bulimic in control, and then you get this mean here that's overall. And you have that overall one, which is the average across both bulimic and non-bulimic teens for each of the subscales. It's comparing these 5 means, one for each neo-PI subscale, combined across both bulimic and non-bulimic males. So that might be of interest to you. You might be like, I want to know how teenage males neo-PI subscales sort of flow, right? What's the order, relative order of them? But why are we doing this study comparing bulimic and non-bulimic males on their profiles if we think they're the same? Well, we don't. This person thought they different. They have all these specific hypotheses. So why is this main effect probably not very meaningful for this study? The answer here is the neo-PI subscale means are combined across both bulimic and non-bulimic teenage males who, or is it whom, I think it's who, we think differ on these subscales, something like that. Does that make sense to y'all? Maybe that would be awesome if it did. Like basically, why would we look at tests that combine them when the whole point of this damn study is we think they differ? So there we go. And of course, it had to go to another line because this thing hates me. All right. So using alpha of 0.05, is there a significant bulimia group by neo-PI subscale interaction? That's the test of parallelism. So we're back down to tested within subjects' effects. Neo-PI by bulimia group, greenhouse geyser, SIG's definitely less than 0.05. Short answer is yes. There does indeed appear to be a interaction. Cool, because that makes this study fun to write up, right? So what does this result tell you about the personality profiles of men with and without bulimic symptoms at this stage of the analysis? So if you remember what an interaction told you with just a regular two-way ANOVA, it told you that the effects of one IV were different at the levels of the other, right? It's actually the same here. The neo-PI subscales, that's one of the IV, differed across the levels of the other IV, that is bulimia group. Right, so that's a really complicated way of saying the profiles of the bulimic and non-bulimic males differ. At least one subscale differs. So that'd be another way to say it. So I'm going to write something like that, simple and easy. What did I do? I hope it didn't screw anything up. The neo-PI subscale profiles of bulimic, and I don't know why I capitalized it. I guess it doesn't really matter, but whatever, bulimic and non-bulimic teenage males differ from each other. That's not a bad answer right there. So cool. That means that they don't have exactly the same profile or pattern of scores across the bulimic and non-bulimic males. So cool, that could be kind of fun. It means we get to do follow-up tests, which is where this just gets crazy. So next one is based on the output table called test of between subjects effects. Let's find that. People remember to ignore this one that's got linear and quadratic and stuff. Go down here. Test of between subject effects doesn't even look like a meaningful table, but it is. It's got the main effect of the between subjects variable, bulimia group. There it is. Using alpha of 0.05, is there a significant main effect of bulimic group, also called the test of levels? No, actually there's not. So no, not less than 0.05. That is the easy answer. So why is this main effect not very meaningful for the study? Well, first of all, it's not significant, so there is no main effect, but what it is the average. See if I can find a place. There's no good place that it gives this, is there? Yeah, there isn't. So what it is the average neo-PI subscale score of bulimic versus non-bulimic males. So it combines 1, 2, 3, 4, 5 for bulimic males, the average of those 5 data points compared to the average for 1, 2, 3, 4, 5, the bulimic males. So it compares the average of these 5 dots to the average of those 5 dots. And so what does the average NEOAC subscale score mean? Well, nothing. There's no mean personality, right? So there's a reason those are subscales. It's because you're supposed to look at them separately because they're very different things. 5 factors. So how do you want to say this? I don't know. Let's try. The two means being compared between the bulimic and non-bulimic teens, teenage males, I guess is what I've been saying, are combined across all neo-PI subscales. So they have no discernible meaning. There is no average personality. That kind of doesn't make sense. Score. So we're going to fill in the ANOVA information below using the SPSS test of between subjects effects output table for the upper part, the SPSS test of within subject effects output table for the lower part. Note that eta squared is equal to that. We got to round the greenhouse geyser degrees of freedom to the nearest integer. To calculate total sum of squares, add everything in the SPSS column, the whole darn thing, between and within effects. However, to calculate the total degrees of freedom, you need to go back to the SPSS output tables again and add all this versus the assumed degrees of freedom for the effects. Okay, that's a lot of words. Let's see if we can make sense of this. So up top, we got bulimia group and error. That's come from tested between subjects effects. So let's start filling stuff in. Bulimia group, sum of squares is 24.33. So 24.33. The degrees of freedom for that were 1. The mean square is also 24.33. The F is 0.44. Does that get a star? Negatory. We can't calculate this yet. Our error is right here, 3908.83. 3908.83. Sum of square, or excuse me, degrees of freedom is 71. The mean square is 55.05. And our no F value, no eta squared. Not doing too bad. I should probably shut off this background so you don't have to look at the stupid grid lines. There you go. So far, so good. We have to now do the within subject effects, and this is where stuff gets a little crazy. Go to the test, nope, not contrast, test within subject effects, greenhouse geyser lines for NeoPI, that's here. What's our sum of squares? It's 57.53.14. 5753.14. It's a big number. Degrees of freedom is some decimally looking thing. So you're supposed to round this to the nearest integer. So 2.8 rounds to 3. So we're going to put 3 there. Our mean square is 1438.29. 1438.29. Nope, I screwed that up. Oh boy. Right here, 2028.33. Yes, that looks good. 2028.33. Our F is 59.03. 9.03. That sig less than 0.05? Yes, it gets a star. We can't do eta squared yet. How about the interaction? That's here. Remember to do greenhouse geyser. 571.33. Our degrees of freedom is 2.8. So it's going to round to 3 again. Nearest integer. Here we go. Our mean square is 201.43. Our F value is 5.86. That's significant. You bet it is. Gets a star. Error within subjects, greenhouse geyser. Oh God, 6919.51. 6919.51. What's our degrees of freedom for that? It's roughly 201. Around that to the nearest integer. Our mean square is 34.36. And now we're on the bottom row. So this is where stuff gets a little crazy. We have to add all 5 of these things to get this number right here. So let's do that. Let me get my calculator going. So, and I'm going to do this twice because I might mess it up. 24.33 plus 3908.83 plus 5753.14 plus 571.33 plus 6919.51. I get 17177.14. 17177.14. That's our total sum of squares. So let me do it one last time. 24.33 plus 3908.83 plus 5753.14 plus 571.33 plus 6919.51. Got the same number. Looks right. So here's where it gets even weirder. So we got to add these, but for these ones right here, we're supposed to use these the assumed ones. So it's actually, instead of 3, 3, and 2, 1, it's going to be 4, 4, 284. So let's add them up. 1 plus 71 is, well, I'll just do it the hard way. 1 plus 71 plus 4 plus 4 plus 284. I get 292. Let me do it again just in case. 1 plus 71 plus 4 plus 4 plus 284. Oh God, yeah, I got something totally different this time. So what did I screw up? Oh, let me try it a fourth time. 1 plus 71 plus 4 plus 4 plus 284 is 364. So like, obviously I got that one twice. That's apparently the answer. Okay, so eta squared is the sum of squares for an effect divided by the sum of squares total. So this one right here. And let me see if that's passes. 271. That's not 364. What the hell am I doing wrong here? I don't know. This is supposed to be, yeah, I see. It's supposed to be 284. That is right. Good Lord. You would think I didn't teach the class. All right, so 24.33 divided by 17. Divided by this number right here, 177.14 is 0.0001. That's just going to be 0.00. Next, down here is NeoPI subscale is 5753.14 divided by 17177.14 is 0.33 is what we'd round that to. And then finally, for our interaction, it's 571.33 divided by 17177.14 is 0.03. And let me redo these just because I seem to have a habit of screwing this up. So boom, boom. And I don't have a friend like you guys I can check my answers with. So, all right. So let me just try it one last time. 24.33 divided by 17177.14. Yep. 5753.14 divided by 17177.14. 0.33. Yep. And finally, 571.33 divided by 17177.14, boom, is 0.03. So it looks like I actually got that right for once. That's crazy, but that's the table. So we're going to test hypotheses 1 through 5. And these are the ones that when we added compare bulimia group, whatever the heck it was, we get these automatically on our output. These are the between lines, one test for each NeoPI subscale. So go down until you find something called univariate tests. There it is. So what is this? Well, this is for each NeoPI subscale, it's a, well, read the bottom. Each F tests the simple effects of bulimia group within each level of combination of the other effects shown. Well, it compares bulimic and non-bulimic males for NeoPI subscale 1, 2, 3, 4, and 5. What is 1? I recommend you actually go ahead and put something. Oh God, I can't. Can I put N? Nice. E O A C. Cool. That's going to make this a hell of a lot. Oh man, why did it do that? C. Okay. All right, that's going to make this a lot easier to read, right? So did I tell you to do that here? No, I guess I don't. Not a bad thing. The Bonferroni adjusted alpha level is 0.05 divided by the number of levels of the within subject's IV. So that is 0.05 divided by 5 is 0.01. So the answer here is 0.01. That is our Bonferroni corrected alpha level. What is going on here? That we are going to use to interpret these simple effects tests. So for hypothesis 1, determine, just put a yes or no, it's supported. Bulimic males were higher on neuroticism than control males. First of all, SIG, is that less than 0.01? No, not supported. This is really how dissertations go, by the way. You're like, oh man, swiper needs to keep swiping. How about E? Bulimic males are higher on extroversion than control males. There's E. Is it significant? Less than 0.01? No. Hypothesis not supported. They don't even differ. How about bulimic males were lower on openness than control males? There's openness. Is that less than 0.01? It is. Cool. So were the bulimic males lower on openness? I'm going to go to the picture. And actually, I'm going to put the NEOAC in here too, because I can't read this stuff. Thanks, SPSS, for doing things like this. N E. Here's O. Wanted. I'll keep putting these in. A and C. So for O, sig's less than 0.01. So we know that the bulimic and non-bulimic males differ on openness. Let's look at the means. So who's higher? Bulimic males are higher, right? These two things are significantly different. Bulimic males are more open than controls. What did I hypothesize? Bulimic males would be lower. So is this hypothesis supported? No. The researcher got in the wrong direction. So maybe I'll add that. No, wrong direction. They chose wrong. they thought bulimic males would be less open to new experience. Turns out they were completely wrong. They're actually more open. How about the next one? Bulimic males would be higher on agreeableness. There's agreeableness, not less than 0.05. So no, not supported. How about bulimic males would be higher on conscientiousness? Do they even differ? No, not supported. So not a single one of these was supported. 4 of them because it wasn't significantly different. One of them, yeah, the groups did differ, but he said the opposite of this, right? He said that bulimic males would be lower. And looking at the plot here, bulimic males are higher. So got it wrong. So, oops. Moving on. So hypothesis 7 is where stuff gets just absolutely crazy. We got to do repeated measures ANOVAs, and then we got to do, a bunch of follow-up t-tests, and it just gets kind of nuts. So what do we want to do first? So I guess let's just follow the damn instructions. So what are we testing here? These 2 hypotheses. The most salient characteristics for bulimics would be E and O. The most salient for control males would be A and C. The way you do this is you compare along the lines. For bulimic males, compare these 5 points. For control males or non-bulimic, you compare these 5 points. Let's do it. So was this, select data on the top menu in split file. Data, split file. Select compare groups, put them between subjects I, B in this box. So bulimia group. Do groups based on, click OK. Now everything we do, it's going to do separate for bulimics and non-bulimic teenage males. SPSS will start to file, blah, blah, blah. So I tell you to go back into analyze. And general linear model, we want a repeated measures ANOVA for these guys, and then a repeated measures ANOVA for these guys. So we go back in to general linear model, repeated measures. This is fine. We still have NeoPI, so click define. We have to take out or remove bulimia group from here. And then in the plots button, we need to move the within IB NeoPI from the factors box to the horizontal axis box. So there, NeoPI to the to the horizontal axis box. Boom. And click add and click continue. And the options, I tell you, unclick homogeneity tests. Otherwise, you get all sorts of nonsense. Click the OK button or continue, and then click OK. So note we don't hit paste. We actually click OK. Do not turn off your split file. So here's the output that we get. And what is it? We get means for bulimic and controls for each of the subscales. We get stuff we ignore. We get 2 Mockley's tests. We get tested within subjects effects table, and that stupid thing with quadratic. We get plots. We get all sorts of stuff in here. So let's go ahead and start answering questions. Was the scarcity assumption violated for either follow-up ANOVA? Here's our scarcity assumptions tested by Mockley's. These are both less than 0.05. So yes, scarcity assumption was definitely violated for actually both of the follow-up ANOVAs. Not shocked. If you do enough of these, it kind of happens a lot. So write the results. Mockley's using the APA format. So let's go ahead and do the first one. There is the general format for doing these. Our W is 0.27 for bulimic males. So 0.27. Degrees of freedom is 9. Our N. Where do we get that? What's our N? What's our number of bulimic males? Where are we getting that? Up here. Bulimic, there was 41 total of them. So this number right here is 41. 41. And, whoop, too far. Our chi-square is 50.94. And our P is definitely less than 0.05. All right, so to super cheat, I'm going to copy this on over here, paste it down here, and just change stuff. Here, we've got a Mockley's of 0.53. We've still got 9 degrees of freedom. The chi-square, that was 18.82. Oh God, wait, I forgot this. So the N, what's the N for the control males? It's up here somewhere. There it is, 32. There's 32 control males. So we'll change this to 32. All right, our chi-square, getting back to that, is 18.82. So I'll change that. P is again less than 0.05. Based on your answers above, what ANOVA result should you therefore interpret for the follow-up ANOVAs is going to be greenhouse geyser again. It's like always greenhouse geyser. Greenhouse geyser. Boom, boom. All right, so let me hit save. Next, based on the alpha table called tests of within subjects effects. That's here. What are we doing? The Bonferroni adjusted alpha level is 0.05 divided by the number of levels of the between subjects IV. How many levels are there of the between subjects IV? There's 2. 1, 2. So 0.05. 0.05 divided by 2 is 0.025. That is our alpha level we're going to use. Bonferroni corrected to interpret these 2 repeated measures ANOVA follow-up tests. So using our Bonferroni corrected alpha level, did bulimic males have at least one NeoPI subscale mean that differed from at least one of their other subscales? All right, here's our bulimic males. There's greenhouse geyser scooting across. SIG's definitely less than 0.025. So yes, one of the bulimic males subscale scores differ from at least one of their others. So I will go ahead and put in that in. Oh, well, so first of all, I'll say yes. Get that answer down. And let's put it in APA format. And I tell you to round greenhouse geyser to, yeah, we know this. All right, so, geez. Oh man, give me all sorts of problems tonight. All right, so we have an F with, we'll round that to 2 and 93 degrees of freedom. So let me highlight this so it's obvious. Jeez, there we go. So we have an F with 2 and 93 degrees of freedom is equal to, what is the F value over here? 33.55. And P is less than alpha Bonferroni. What's alpha Bonferroni? 0.025. And of course, you're not going to be nice and highlight that, are you? That is our F. We need that for our APA write-up. So how about control males? did at least one of their subscales differ from at least one of the others? Control males, greenhouse guys are less than 0.025. So indeed, the answer again is yes. So not surprising, write up an APA notation. Let me copy this sucker over there. All right, we have an F with 3 and 99 degrees of freedom. That's what I'm getting. 3 and 99 degrees of freedom. Let me make sure I'm doing this right. 399, yes, is equal to 34.12. 34.12, and indeed, P is less than 0.025. So we got to keep going. Now we know that at least one subscale differs from at least one of the others for both the controls and the bulimic males. We got to do a bunch of paired t-tests to figure out exactly which ones differ from which. So to do that, keep your split file on, go to Analyze, Compare Means, and Paired Samples t-test. And we got to match up all possible comparisons of the 5 neo-PI subscales. Don't do bulimic group. First one is neuroticism with extroversion, neuroticism with openness, neuroticism with agreeableness, neuroticism with conscientiousness. That's your first 4. Then you scoot down one, E with O, E with A, E with C. Let's scoot down to O now, O with A, O with C. Then finally scoot down, A with C is our 10th one. That's what we need. So when I click OK, so make sure yours matches this right here like mine does, and then click OK, and it runs a ton of t-tests. So again, these paired sample statistics, these are our means and standard deviations. Here's correlations, ignore this. These are our t-test results right here. This is what we actually want to be looking at. And I'm just gonna see if I can't make this stuff fit a little better. Not clear. There we go. So I tell you, you need to ensure that these are, they go to 4 decimals instead of just 3. Why? Because, well, you find out in a sec. So double click, highlight all the sig values. And that really didn't work because this keeps going off the page. There we go. And then right click and go to cell properties. And that's apparently wrong. Or no, format value. That is right. And change decimals to 4. Apply. Okay, now we got 4 decimals here. I guess. Yeah, I guess. I don't know why it doesn't do these ones. I guess just because they're less than. Kill that. And we've got 4 decimals here now. Cool. All right, so the Bonafroni adjusted alpha level is 0.05 divided by the number of paired t-tests for each IV between subjects level to use. So what are we talking about here? How many t-tests are there? There's 10, right? So we're going to do 0.05 divided by 10 is 0.005, and that's why we had to expand the decimals so we can actually see if things are less than 0.005. So let's do our Bonafroni is 0.005 right there. And of course, now you're going to be lame. There we go. Use the results of these follow-up tests, multiple comparisons, and the means plots to describe the neo-PIA personality profiles of each group. All right. Good luck. This is like the craziest thing we've possibly ever done in the whole class is this stuff right here. So what do we got here? We have for bulimic males, we have 10 paired t-tests. For non-bulimic males, we have 10 t-tests. And we are looking for SIGs here that are less than 0.005. And you're going to need a piece of paper to do this. Let's start there. So looking at bulimic males, let's identify the differences that are less than 0.005. So neuroticism versus extroversion, openness, agreeableness, conscientiousness. right? That's those, all four of those are neuroticism, significantly less than 0.05 than the other subscales. Let's look at the plot. Where's the damn plot? Oh, it's up here. There's our bulimic males. Neuroticism, let me fill these in so these make a little more sense because still got these numbers again. And why you do this to me? N E O A C. All right, and of course it didn't update that last one, so let me try again. Kind of have to click off it to get to work. All right, let me do that also while I'm thinking for our control males. Nope, there is no R, E. Jeez. O, A, C. Again, click over. All right, close it. All right, now hopefully this makes some sense. So for bulimic males, the t-test indicated that N was different from all the other ones, right? So N was different from E, O, A, and C. Look at the means. N was lower than E, O, A, and C, right? That is first finding, is that they're lowest in N. Bulimic males are lowest in N. Oops, in N, so neuroticism. All right, any of these other things less than 0.005. Let's see. So these were all the neuroticism ones here. No. None of these are less than 0.05. This one is for the next one. So none of these other ones are. So basically their personality profile is as follows. They're lowest in N, and then they're equally highest in E, O, A, and C. Equally highest in E, O, A, C. Not a very interesting personality profile. I think we saw this during the lecture for how teenage kids thought they'd be when they were old. They're lowest in N, but E, O, A, and C, none of these different from each other, and they're all just sort of like blah, highest. So remember, there was a hypothesis 6. Hypothesis 6 was that were the most salient, that is highest traits of bulimic males E and O. It's a little weird to answer this because they weren't the only highest. So I guess you could say yes, E and O were the highest personality traits, but so were A and C. So yes, they were they're not the highest. I mean, they're God, how do you answer this? Were the most salient traits of bulimic males E and O? Actually, I'm going no. It was E, O, A, and C were highest. I think that is the best answer here. All right. And you're like, why? Well, E and O were highest, right? But no, they set the highest. So they were highest, but also A and C. So they weren't like the most high ones. So how about neo-PI subscales for the control males? It's going to be this. You can already tell it's going to be more interesting, right? So let's go down to their paired t-test. A little crazy. We're looking for ones that are less than 0.005. So first of all, you got neuroticism versus E, O, A, and C, all less than 0.05. Let's knock that one out. What's going on? Here's the controls. N is different from E, O, A, and C. They are lowest on N. So I'm going to go ahead and put lowest on N. All right, next. Next, so lowest on NEOAC. All right, so where are we? We're at extroversion and openness differed. So extroversion differed from openness, extroversion differed from agreeableness, extroversion did not differ from conscientiousness. All right, I think that's it. Extroversion differed from openness, right? Extroversion differed from agreeableness, but extroversion did not differ from conscientiousness. All right, so let's look at what's going on. So extroversion, this guy right here, differed from openness. So E was higher than O. Extroversion differed from, God, I can't remember anymore. Extroversion openness, significant, less than 0.05. Extroversion agreeableness, yes, significant, but not conscientiousness. So extroversion also differed from agreeableness. So extroversion was lower than agreeableness, right? So E was lower than A. And I just totally broke my pencil, so give me one sec here. Crazy. So E significantly differed from A. E was lower than A, but E did not differ from C, did it? So E and C do not differ. The sig was greater than 0.05. So E is equal to C. And his lowest, E was higher than O, lower than A, equal to C. Next. E and A, E and C didn't differ. So now we're at openness, right? So openness differed from agreeableness, differed from conscientiousness. Okay, let's see what that looks like. So O differed from agreeableness and it differed from conscientiousness, right? So what's that tell us? So O was lower than agreeableness and conscientiousness. Well, wasn't O also lower than E? Didn't we just determine that? Or E was higher than O? Yeah. So what's going on here? That means if it's O is lower than E and lower than A and C, then their next highest personality trait goes from N to O. Lowest on N, then O. That's their next highest personality trait, I guess is the way to think of that. N, then O. So finally, we know that E was lower than A, but not different from C, right? We have one last t-test here. It is A and C sig. A and C differ. So A is higher than C. A was higher than C. So what do we do now? Well, we got to make sense of this. So E was lower than A. E was equal to C. C was also lower than A. So the next level is E and C. So lowest on N, then O, then E and C, and then highest on A. That's what all this means. This is their personality profile. Crazy. Lowest on N, then next highest was O, then they're equally next highest on E and C, and they're highest of all on A, agreeableness. So the hypothesis was that the most salient traits of the control males would be A and C. Was that what they found? No. They found, I would say this is partial support, maybe something like that. Partial support, highest on A, but not C. Not C. All right. So let me just repeat that after I highlight this, see if it makes sense. So they hypothesized that A and C are going to be the two highest, right? And were they right? Partially. A was the highest, but not C. So I'd say partial support, highest on A, but not C. So finally, you just had to write all this up. Let me show you how to change the graph, just in case you didn't know how to do it. To make it APA compliant, double click on it. Got to get rid of this and put subscale score, or mean subscale score, I guess. Mean subscale score. Cool. We got to start this at 0. So click there, scale, start it at 0, click apply. What we got next? We got to get rid of this thing up top. So I just highlight it, hit delete. We got to get rid of these grid lines. So you go to options and hide grid lines. This is not really a word. So you could call it neo. I think the technical spelling is neo-pi subscale. And you could write out the full words if you wanted. Finally, we got to get this within the range of the figure. So you click down here. So you get these boxes and then you drag this lower one all the way over, boom, close. You got yourself an APA format plot, right click, copy, paste that into your APA write-up. So if you survive this, you're awesome. This is a very difficult assignment, but I'll tell you what, profile analysis is one of the most popular analyses that students do for their dissertations because it just kind of makes sense, I think, for them. At least for psychology. So that's it. That's our last stat that we actually learn in this course. So I hope that made sense. And again, if you have any questions, hit me up in the chat and discussion, and I'm happy to help you and get you through this. So good luck.